Hello, this is Nikki Jackson with Southwest Tennessee Community College, and I am going over section 3.3 from Math 1710 Pre-Calculus Algebra. As you notice, you see the date in the agenda for this particular session. This session is a pre-recording for session 3.3 because we were going to do live virtual discussions of section 3.2. So this will be shared with students in this particular class as a YouTube link. So let's go ahead and get started. Make sure that you use your calculators because they are needed. This classwork is also posted within your teams, so feel free to follow along with me. So what section 3.3 is dealing with is all dealing with systems of equations. So if you realize something about system of equations have more than one variable. For example, systems will have both x, y, and z, perhaps more. Thus, the system of equations because you have more than one variable. One of the ways to actually do systems of equations is called a matrix. Now, I'm not talking about the movie. I'm literally talking about rows and columns. For example, if I zoom in on these two matrices, you have A and you have B. Matrix A is going to be a 2 by 4 because you have 2 rows and 4 columns, making matrix B a 4 by 2 because you have 4 rows and 2 columns. Instructions on how to create a matrix is also posted in your teams under files, but let me show you how to put these in. So the first thing you need to do is cut your calculator on. So ta-da, I'm going to cut it on. Hit your second key and then matrix. So let me move my calculator up so you can see it. So again, second and matrix. This list should pop up. We're going to go over to edit, hit enter. So for matrix A, this is going to be a 2 by 4. So hit 2, enter, 4, enter. And you may notice how it's going to set up just like you have it. So we're going to put these numbers in as listed. Make sure you hit enter each time. So we're going to put our first number as -8. So let me move my calculator again so you can see the numbers. This is your negative key, where my finger is. So we're going to have -8, enter, -8, enter, -4, enter, 2, enter, 7, enter, 1, enter, 3, enter, and 2, enter. So now we have our matrix A. To exit out of that F, you're going to hit second, then mode. That's going to quit. Now we got to put in our 4 by 2 matrix, which is matrix B. So second, matrix again, go over to edit, go down to matrix B, hit enter. This is going to be a 4 by 2. So 4, enter, 2, enter. Put your numbers in as listed. So 1, 5, 10, 6, 2, 1, 3, and 7. So notice I'm going from left to right for each one. Now, we got to figure out how we got these answers right here. So notice for answer A, you have -90, -78, 29, 58, because you're multiplying A and B. For the answer BA, you have all of these, which is a 4 by 4 matrix, because you multiply B and A. Notice how order is important. So second, quit, and we're going to figure out how to do this. So again, the first one is A times B. Again, notice how A comes first. So second, then matrix, hit enter for matrix A, hit your times key, second matrix, go down to matrix B, hit enter. Now you see you have A and B. Hit enter. Voila, we have the exact same matrix. Now let's do matrix BA. Again, notice the order. So we're going to multiply B times A now. Now the reason why the numbers are different, notice this one is a 2 by 2. So you're looking at your first rows and your last columns. The next one, when you rewrite it, it's going to be a 4 times 2 and a 2 by 4. So it's going to be a 4 by 4. So you're looking at the outside of the numbers. So again, look at the order of it. So again, second matrix, go down to matrix B because you want that to be first. Hit enter. Hit your times key. By the way, the times key is not necessary sometimes. Second matrix. Hit enter for matrix A. Hit enter again. And there you have your 4x4 matrix. So yay! We got number 1 out the way. Part B. And I'm saying part B, my apologies. Number 2 and number 3. Read those carefully. It's asking you to find the determinant. So make sure you watch your videos in the Pearson to get a better understanding what the determinant is. But for these, you're going to use your calculator once again. So for 2, that is a 2x2 matrix. Notice how it's the same thing. It's just repeating itself. And this one is a 3x3 matrix. So we're looking at the rows, then the columns. So let's put in the first matrix. We're always going to use matrix A because matrix A is the automatic default one. So we're going to go again, second matrix, go over to edit, hit enter. Now we're going to make it a 2x2. So 2 enter, 2 enter. Put your numbers in from left to right. There we go. Second mode for quitting. Now we have to find the determinant. So hit second matrix again. Using your right arrow key, go over to math. This menu should pop up. The first thing you should see is determinant. So hit enter for determinant. Second matrix again. We had matrix A is our 2x2, so hit enter, enter again. Notice how your determinant is negative 33 as listed. So let's try one more example. So remember, matrix A is always your default. So second matrix, go over to edit, hit enter for matrix A. Now we're going to change it to a 3x3. And the reason why it's a 3x3, you have 3 rows and 3 columns. So put your numbers as follows from left to right. Make sure you hit enter each time you do it. If you have an arrow, make sure you put in negative, not the minus sign, because it will wind up being wrong. By the way, here's your minus sign right here. So I have my numbers up. To exit out, second mode, notice how that says quit. Go back to second matrix. Go to math, hit enter to determinant. Second matrix again, hit enter for A, and hit enter again. You now have a determinant of negative 28. Please be mindful. If you do it the long way, meaning manually, you must watch the videos that are in Pearson. Here goes one more example of a determinant. So I'm going to skip that one for right now because we can do that just like we did examples 2 and 3. We know that it is a 2x4. Number 5 is self-explanatory. It's just the way that it's written out. It says determine the values of x and y to make the equation true. Well, notice how you have your equal sign between each of these. So your x is going to equal negative 6. There you go. And then 8 equals y. Just do the reflection of that, so y equals 8. Now that leads into this one. It says write the system of equations, linear equations, augmented matrix on the right. You're going to use x, y, and z for your variables. So let me write this out across the top to make it a little bit easier to understand. We're going to have this as our x column, our y column, our z column, and this is just going to be your constants column. This is what everything is going to equal. So when I write that out as a system of equations, for your first row, you're going to have 2x. Notice how you do not have a y because that is a 0, plus 3z. I'm getting the z because that's my z column, equals negative 12. So we can put a check right there for that answer. Your next one is going to be your second row. Notice how there's a 0 for the x, but you're going to have 1y, because I see 1y right here, minus 6z equals 13. So I'm going to put a check right here. Then our last equation, or system of equations, is pertaining to the last row. So you're going to have 6x, because I see a 6 in that column, a plus, because it's a positive 7y. You do not have a z, because you see the 0, and it's going to equal 4. So that is your answer right there. So you went from augmented matrix style to actually equations. Next is asking you to find the solution set. So take a moment to actually read it, because reading is fundamental. So while you're reading that, think about how you can make this an augmented matrix. The other thing that it's asking you to do, where you can do this using your Pearson independently, you can use the Gaussian elimination or with substitution. Well, of course, I'm going to use the calculator way, but again, watch the Pearson videos to show you how to use the elimination and substitution form. So the first thing I'm going to do is rewrite this as an augmented matrix. So remember, you got x, y, and z as your variables, so we can see that. So you got your x column, y column, z column. Then you have what it equals. So using your first row, I see 1x, I see 1y, and I see a negative z, then I see a negative 3. So that's my first row. Second row, I see a 3, a negative 1, a positive 1, then it equals positive 3. Then for your last row, negative 1, because it's a negative x, 3, negative 2, and then 1. Then I'm going to close it with my bracket. So what we've done is just created an augmented matrix. To solve it in finding our solution set, we're going to use reduced row echelon form. And of course, we're always going to use matrix A for our default matrix. So again, that RREF stands for reduced row echelon form. So let's see if we can remember how to put it in. So we know we're going to hit second, the matrix, use your right arrow key to edit. I might need to catch up. I keep hitting it too many times. We know that this is a 3 by 4 because you see 3 rows and 4 columns. So 3 by 4. So now we're going to put our numbers in it from left to right. So I have all my numbers in. Second mode, because that's your quitting. Second matrix. Use your right arrow key to go to math. Go all the way down until you see RREF, not just REF, but RREF. Hit enter. Second matrix again. Now remember, we put this in matrix A as our default matrix. So hit enter, enter again. Look at your last column. So my x is going to equal 0, y is going to equal 7, and z is going to equal 10. So let's see if we can confirm that. By George, we've got it. So x is 0, y is 7, z is 10. Now we're looking at basic operations with this. You have 4 parts, but make sure you read them each carefully. So the first thing you're going to do is input your A and your B in. So this one is going to, both of them, by the way, are 3 by 3s because you have 3 rows and 3 columns. For the sake of time, I'm not going to be able to go over that. But it's going to be very similar to what we did for the first example. This one is pertaining to what we did last week. Well, I'm saying last week, but in section 3.2. So if I rewrite this using the like basis, I can rewrite it saying 7 to the 4x minus 2 power equals 49. Well, I know that 49 is a perfect square. So I can say that is 7 to the second power. Notice how both of them now are bases of 7. So I can eliminate the 7. And once I solve for x, so add 2 to both sides, 4x equals 4, I know that x equals 1. So this is pertaining to section 3.2. Going back to our matrices now, aka system of equations, we're looking at matrices A and B. Both of those are 2 by 2s. So once again, make sure that you follow the order of that, because again, this is pertaining to what we did for example 1. Number 11, though, is slightly different. Slightly is not even the word. It's a lot different. Like a lot different. Now the reason why it is a lot different, because we did one just like it, but I may have gone too fast with those examples. But you're trying to solve for your system of equations. So with that being said, we have to identify how many rows and how many matrix columns we have. So we have 1, 2, 3 rows, and we have 1, 2, 3, 4 columns. So let's figure out how to put it in the calculator. Remember, our default matrix is always going to be A. So hit cut it on, second matrix, go over to edit, hit enter for matrix A. Once again, we know that it's a 3 by 4, just like our last example that I did. Put it in as listed. Notice you're only using your numbers, which are your coefficients. Make sure you hit enter each time you enter it in to lock it in. Once you enter it, hit second mode, second matrix, go over to math, go all the way down till you see RREF. You have to make sure you have your 2 R's. Second matrix again. We just input all our information under matrix 1, so we're going to hit enter again, and boom, bam, pow, the magic of the calculator. Notice your last column, you have x is 1, y is 5, z is -1. So that sums it up on how to use your calculator for a system of equations.